Okay, thank you so much. I would like to welcome you in this session. Today I'm going to deliver a talk on the topic of analysis of cross-lingual and multilingual text classification approaches using transfer learning paradigm. And the scope of these approaches are high and low resource languages or under-resourced languages. Okay, that is the outline of my talk. First of all, I will introduce about the domain. Then I will describe in detail the challenges with low resource languages, and then cross-lingual approaches. How many types of cross-lingual approaches are available? Then multilingual learning approaches, and then I will describe a design of a case study basis on the multilingual paradigm. And then at the end, I will conclude my talk and will discuss the future prospects in this domain. Well, let's start from this world languages landscape. Here you can see that is the statistics of 12 languages published by the Washington Post in 2022. Here you can see that the proportions of speakers or the statistics of speakers as compared to the other languages, considering Chinese language, and considering all of its dialects, you can see this language dominates as far as the speakers or the native speakers are concerned. And you can see the number of speakers related to English language, also Russian language, Bengali language, and especially Hindi and Urdu. Both languages are combined, and you can see the number of speakers. So from this landscape, only the English language is the high resource language. All other languages are under resource or low resource languages. So it's mean considering this landscape, the low resource languages or under resourced languages dominate. But usually the main work, the people are producing papers in English language mainly. And according to a recent survey, that more than 60% of the paper published recently, those are in English language. That is the problem with the low resource languages, that they are sometimes totally ignored. So considering the low resource languages, there are several challenges with low resource languages. I will describe those challenges in the next slide. One of the challenges, lack of annotated data set, lack of tool for pre-processing. So all these challenges results with the poor performance with NLP models. That is the problem, that NLP performance could not perform effectively with state-of-the-art performance. It could not deliver. So we can handle this issue using the cross-lingual learning methodology. And what is the cross-lingual learning methodology? It is a paradigm. It is a approach that transfer knowledge from one natural language to another natural language. That is the basic definition of cross-lingual learning. And what is being transferred? It is the transfer of knowledge, basically help us, especially for lack of annotated data set. And it also enables the researchers to create such intelligent systems for under-resourced languages. Okay, here I enlisted some common challenges with under-resourced languages. The first of all, as I already described, that it is the lack of annotated data sets. That is the basic, or you can say the first challenge. Then the essential resources and accurate text pre-processing toolkits and the softwares, those are not available usually for under-resourced languages. Especially, I am working in Urdu language. I am also working in Russian language. And at the same time, I worked on Arabic language. So With these low resource languages, we encounter the deficiency of toolkits and processing softwares. That is the second challenge. Third one is that some languages have multiple scripts. Social media users usually write their opinion, usually share their views by using those multiple scripts. Like Urdu is available in two scripts in Nastaliq style, that is in Arabic, and the other is Roman style. Similarly, Arabic is also available in two styles. So that is another challenge. The fourth one is that by the availability of these multiple scripts, the users of social media, they usually share their viewpoints by using these multiple scripts. So that initiate the issue of a code mixing problem. That a comment, a post, a tweet contains multiple versions of a language, and it is really hard to get insight, to mine from those from that comment, from that post for a specific task. And the more important related to the implementation is the pertinent, means the state of the art language models or transformer models are rarely available for these under-resourced languages. Okay, so before going to the types of the cross-lingual learning approaches, I want to define some definitions. These definitions are necessary to understand those types of cross-lingual approaches. So whenever we are dealing with transfer learning, we should keep two things in our mind. The first one is the domain, and the other one is the task. So usually in common scenarios, our domain and task are in the same language, means our training data and our testing data, or we can say our source data or the target data are in the same language. This is a basic approach. But for transfer learning, our either domain or the task should be different. Means either our domain should be different or task should be different. For example, when our domains are different, means our domain differs, then we say it's a cross-domain learning. For example, a sentiment analysis model can be trained on reviews data set, but it can be applied, it can be tested on the tweets data set. That is the cross-domain transfer learning. The other type is cross-task learning. In this approach, there are two tasks related to, one task is related to the source language, that is the training data. The other task is related to the target language, that is the target language data. For example, we can say that we are going to train a name entity recognition model and use auxiliary, the part of speed tagging data during the training to improve the performance. So these two tasks differ, but both tasks are being considered at the same time during training time. So what is, after going through these definitions, these basic, what is cross-lingual learning? So for cross-lingual learning, when we are going to apply the cross-lingual learning, we should keep in mind that there should be at least one pair of different languages. Then we can apply cross-lingual learning. So it means there should be a room for transferring of knowledge from one language to the other language. So if the target language instances or the target language the language samples are not present in the during the training time, then we can say that it's a special case of cross-lingual learning, that is zero-shot cross-lingual learning, in which the target language instances are not present. But usually in some cases, we have input and output of the task in different language. We input in different language, the output of the task is in the different language. What is being transferred? So we want to know that why and how and what we are going to transfer from one language, from one source language to the other target language. So there are mainly 4 types of approaches under the paradigm of cross-lingual learning. The first one is label-based, feature-based, parameter-based, and representation-based. So let's go through each type of cross-lingual learning one by one. First, just go to their basic definitions. In label transfer, we are interested to transfer the labels of the data set, annotations of the data set. We are interested to transfer from the source language to the target language. Then when we apply this methodology, we can say that we are applying label transfer. Then the next one is feature transfer. Instead of label, we are interested to transfer the features from the source language data to the target language data. The third one is parameter transfer. This approach is applied only for those models which are parametric model, because it could not be applied for non-parametric model like decision tree. For decision tree, we cannot apply parametric transfer because it applies for parametric model. So in this approach, we are interested to transfer the behavior of the model from source language to the target language. And the last one is the representation language. So we are interested to transfer the hidden representation from one source language to the other source language. Okay, so let's discuss each of the approach with little detail. As I described earlier, that with label transfer, we are interested with the transfer of the label between the two different languages. So how it is being transferred? So first of all, we have to establish a correspondence between the source language instances and between the target language instances. One-to-one correspondence. We have to establish this. After establishing this correspondence, then the sentence, for example, and its translation have the same sentiment. Means the correspondence is now established between the source language and the target language instances. Then we can share the labels. There are three subtypes of this approach, that is the label transfer. The first one is LT model, LS model, and parallel model. In these three approaches, the basic methodology is the correspondence establishment between the source language instances and the target language instances. But there are differences also. What are the differences? That for LT model, this model can be created, can be constructed. That first of all, we need an existing annotated data set in the source language. We have one source language, target language. In the source language, we need an annotated data set to apply this methodology, that is LT model. So after that, we need to establish the correspondence between the source language data and the target language data, because the target language data is without annotation. There are no annotations for target language data. So after establishing this correspondence, we project the annotation from the source language to the target language. And we can say that we are going to transfer the labels during the training time. That is LT model. The next one is LS model. The difference between LT and LS model is that in LS model, we are going to transfer the label during inference time, during prediction time. And in LT model, we are going to transfer the labels in the training time. The third one is the parallel mode. In parallel mode, we are interested to use both source language instances and the target language instances at the same time, the input of our training model. So, but this approach is least frequently used for transfer learning of labels, but it is an approach. But it is not frequently used. The second methodology is the feature transfer methodology. First one was the label transfer. This one is the feature transfer methodology. So this methodology is almost same to the label transfer methodology of the LT model, but the difference is that here we are not interested to transfer the label, we are interested to transfer the features. So annotated samples from the target language, not from the source language. From the target language, are given additional features from the source language. So it's a transfer of features from the source language to the target language. These additional features are combined in the target language so that the model trained on the target language could be in a better way to predict for future instances. So that the same process is adopted for in the inference stage. The next one is the parameter transfer methodology. So here we are interested to share the parameters of the model between the source language that is trained on the source language and that is trained on the target language. But remember that this approach can be applicable for parametric models, parametric supervised learning models. So like the CNT and any other model, those are non-parametric, we cannot apply this. So there are three approaches in this methodology of a transfer, parameter transfer. First one is zero shot, the second one is joint learning, and the third one is cascade learning. Zero shot, as I already described, that there is no instance of target language during the training time. So we train model on the source language, and then we apply that trained model to the target language to predict the instances, to predict the label of the instances. So it is also called a direct transfer. Joint learning means we are going to combine the instances of source language and the target language at the same time. So the model trained on the source language, model trained on the target language, though both models are parametric model, this is the basic requirement. So they are going to share the parameters. So when one model updates its parameter, it affects the other model that is in the target language. In cascade learning methodology, we apply the same both data set, source language, or we can say the training data set, or target language, or we can say the testing data set. We apply both, but not at the same time. We train or we pre-train our model with the source language data, and then we fine-tune our model with the target language data. This is the cascade learning methodology in parameter sharing paradigm. So the last methodology is the representation transfer methodology. Here we are interested to transfer some hidden characteristics, hidden representation of the models between the source language and the target language. Like we can say the hidden distributed representation created by the neural network, we are interested to transfer this kind of representation. Then if we are interested, then we can use this representation transfer methodology. But usually there is a drawback, there is not drawback, there is a limitation with this methodology that it is usually not being used as a standalone. It is used as the extension of the other methodology, like we can use label transfer with this representation, or we can use the parameter-based transfer methodology with representation transfer methodology. Okay, then let me introduce you the multilingual text classification. That is the special case of cross-lingual. Up to now, before this slide, we discussed the four methodologies of cross-lingual learning. Multilingual text classification is also a special case of cross-lingual learning methodology, but there is some differences. So here we have annotated data set in multiple languages. We are going to design a classification system for more than one language, and usually this paradigm is being applied for under-resourced languages. So there are three approaches for, in multilingual text classification. The first approach emphasizes that we need to design a separate classification system for each language. This is the conventional approach. For example, we are going to perform the threatening language identification task, and we have a data in English language and Russian language, then we need to design two classification systems, one for English language, one for Russian language. The second approach emphasizes that we can deal this issue by designing one classification system that handles the all languages. That is really difficult. That we are going to handle the multilingual, that the multi-text data at the same time. So that is the second approach. We can say it as a joint multilingual approach. The third one is the third approach adds the translation steps for classification. Means we are interested to translate all languages in one universal language, and then we can design a one classification system. So this is the third approach in multilingual text classification. Okay, so these are my recent contribution in multilingual text classification. Recently, these are two contribution in this domain. Both are in Cuban journals. Next, I am going to shortly, I am going to describe, to share the design of a multilingual hope speech detection for English and Russian language using this multilingual methodology. So what was the objective? The objective was to handle the issue of multilingual hope speech detection in Russian and English language using the transfer learning paradigm, because the objective is to use the transfer learning paradigm. So for this transfer learning paradigm, I explored two methodologies related to this multilingual multilingual text classification, the second one and the third one. This one is joint multilingual, and the third one is translation-based multilingual methodology. So that is the second objective. Then here I added the proposed diagram of multilingual hope speech detection in English and Urdu language. You can see, I just briefly describe this block diagram. Here you can see the English and Russian YouTube comments. We use YouTube data for English and Russian language hope speech classification. So after that, the pre-processing steps are added. Then we are interested to apply two methodologies. The first one is the joint multilingual, and the second one is joint translation based methodology. In joint multilingual, we combine English and Russian data at the same time in one data set, and then we apply the required steps before applying the fine tuning of the transformer model. So we apply the XLM Roberta, fine tune it using a grid search methodology, and then it performs the classification. For translation-based methodology, we divide our task into two subtasks. Here we first, because we have two data sets, English and Russian. In first step, we translate the Russian data set into English and combine it with the original English data set. Then we perform the other steps of related to fine tuning, and we perform the classification. So this is purely English data. Then we perform the other step under the umbrella of translation-based methodology. That is, we translate the English data set into Russian and combine it with the Russian data set. Now this is only the Russian data set. Then we perform the fine tuning of language model and perform the classification. Okay, so I just want to describe the problem and some point related to literature survey of this problem of hope speech. Hope speech, you all know what is hope speech. So it is one of the human capabilities that enables one to envision future events and their prospective, so their possible expected outcomes flexibly. That is the hope. So here we, when we surveyed the literature, we found that the hope speech detection was not earlier addressed as a multilingual paradigm. It was addressed as a monolingual paradigm. That was the research gap, one of the research gaps. The other research gap is that Russian language was totally ignored in the literature. So we addressed two research gaps while designing this framework. That is the pseudocode of this proposed methodology. That is the multilingual corpora. Here I added the statistics of the data set. You can see the English data set, total number of instances, hope speech instances, not hope speech instances, Russian language data set, hope speech and not hope speech instances. Then further I added the detail for train, validate and test part of the data set. Okay, now to apply the proposed methodology, we need to apply three language model with fine tuning. One is XLM Roberta, means we are going to we combine our English and Russian data set, and we are going to design a single classification system that will identify host speech in English and Russian at the same time. For this, we apply XLM Roberta. And for Russian data, we apply the Russian Roberta, and for English data, we apply Russian English Roberta. But what is the problem with this application? These models are trained in general perspective, these language models. So for if we want to use them for any special task, we need to perform fine tuning with hyperparameters. But there are two issues with this fine tuning. Whenever we apply fine tuning, we have to be careful because these two issues are there. The first one is catastrophic forgetting. What is this? Because when we are going to fine tune our language model, it could even forget the previous learning. That is the problem. That is for catastrophic forgetting. So to handle this, we have to, because for fine tuning, we unfreeze all layers and then we apply the hyperparameters values, and then fine tuning process will be conducted. So we have to be careful that our language model should not forget the previously learned weight. The other point is the overfitting or underfitting. That is related to the number of epochs. So if we choose so many epochs, our model could overfit. If we choose a very less number of epochs, it could underfit. So we have to choose the appropriate number of epochs so that our model should not underfit, should not overfit. Okay, so these are the hyperparameters, and we apply the grid search methodology to search the values of the hyperparameters. These are the steps how we divide our data set. We divide 80%. We use 80% data set for training purposes, 20% data set for testing purposes. So how we handle overfitting and catastrophic forgetting? For overfitting, we monitor the validation loss, because we train our model, then we perform validation, and for on validation loss, we monitor its performance. And we reach on the conclusion that the 10 epochs are appropriate number of epochs to handle the issue of this overfitting. For catastrophic forgetting, we applied a certain range of learning rates, because for higher learning rates, the language model did not perform well. They lead to convergence failure. So with the lower learning rates, we reach on the conclusion that they better handle the catastrophic forgetting. So these are the comparable models. Let me quickly show you the performance of the proposed methodology and the comparable models. Here, the joint multilingual framework was applied, and you can see the entry of in this table. The last entry is the joint multilingual methodology. You can see it outperformed the all 9 benchmarks considering this joint multilingual, means we combine English and Russian data at the same time. So you can see the F1 score even for class-wise, hope speech, not hope speech, and on macro F1. Okay, then for English part, we can see that it also outperforms the 9 benchmarks. The accuracy and the F1 score, precision recall measures are here. Then for Russian data, when we translated our data English data into Russian and combine it with the original Russian data. Then after that, we apply the fine tuning of Russian Roberta. Here we got the performance that 93.57% accuracy. It also outperformed the 9 benchmarks. Okay, so the concluding this case study, it is we apply the transfer learning methodology to handle the complexity and the overhead of designing a separate classification system for each language. We handle this issue using the transfer learning. So our proposed methodologies, two proposed methodologies, joint multilingual and joint translation based approaches. They presented superior performance as compared to the benchmarks, and the best performance metrics are added in the last point. You can see the accuracy is 93.57%, F1 is 80.2%. Okay, so what are the future challenges related to these cross-lingual learning methodology and multilingual text classification methodology? The first one is multilingual data set. These are rarely available. Usually researchers combine monolingual data sets to design the multilingual data set. They are needed, really needed, multilingual data set at the same time. Standardization of linguistic resources, that is another issue, because if we see before 5 years, if we see that before 5 years, the technologies, the linguistic resources available at that time, and we compare today's state of the art, there is a lot of differences. So we have to standardize because the output and the efficiency really change. Pre-trained multilingual language model. Now on this domain, on this topic, the people are already working, but still it is highly desired that there is a need to design a multilingual language model that that should be trained on multiple languages. And the last 2 points, we need to identify the truly under-resourced languages, because in research community there is a bias that they still consider the European-centric languages as the under-resourced languages. That is the issue. So we should see that there are some Asian languages; those are really under-resourced languages, which I described in the first slide of landscape, that the Chinese language, Bengali language, Russian language, Arabic language, Urdu, Hindi. So we have to see that this is also a challenge, that what are the truly low resource and languages. And multilinguality, there is a limitation with this multilingual framework, that usually researchers report that when we add languages, initially the performance is improved, but at certain number of the languages, when we add it, the performance starts decreasing. So we have to deal this also. So that's all from my side. Questions are welcome.
Thank you very much for your presentation. And the questions from, please.
But since you cannot transfer this.
Yeah.
What level of the language is actually used? Are these words, collocations, n-grams, and how much structure is important? I mean, if we compare just using words or some structural parts of the text.
Okay. We use, it's working? Okay. We use 2 types of methodologies. One, we use the language model. Language model deals this requirement itself, but we also use the word-based approaches, that is the term-based TF-IDF. We computed the most frequent terms, we extracted, and then we give them weight using the TF-IDF, and we also perform the word embeddings. But these approaches are applied after pre-processing, means we drop the stop words irrelevant things from the text, means punctuations, HTML tags. Those are not making sense for whole speech. So after cleaning data, then we apply these frequency-based, which you are talking, frequency-based approaches. Also, we applied the contextual-based approaches. But the main contribution is contextual-based because we applied the language model with fine-tuning.
Yeah, okay, but it so far it looks like a black box approach. So could you, using your approaches, indicate exactly in the text what part is responsible for the hope speech? What words, n-grams, or whatever?
If we rely or depend on some frequency-based approaches, then it is mainly based on the unigram, and then bigram and their relationships. So because unigrams are not standalone can identify whole speech, there should be some context because words can be used interchangeably. So the context should be there because sometimes hope could be described without using some particular words. So we applied several approaches, not one approach. We applied unigram also, bigram also, their weighting scheme, also the contextual approach. But as far as you're concerned, that is a black box. We did not handle the explainability or interpretability of the model. That could be a future work related to this task.
Okay, thank you.
Welcome.
Thank you for your interesting talk. I have two questions actually. First of all, how do you handle the inherited errors and of translating one language to another language during your model training?
Okay, I skipped those steps because of shortage of time. We translated languages using Google Translator. I also we use some deep learning methodologies to translate language from to translate contents from one language to another. But this translation is not enough. We manually edit the text. We use the experts. If we are dealing with English data, we use the English expert to manually read and go through those contents and address the issues. And for Russian data, we also use the Russian experts to handle those issues because the only translation does not work.
Yeah, that was my point. Okay, thank you. And second question, somewhere at your presentation, you mentioned that model may forget or may underfit and overfit. How can you distinguish between these two cases during the training of the model?
Okay, so for catastrophic forgetting, we deal this issue with the learning rate. When we apply higher learning rate, then we reach on the conclusion that the model does not converge. The performance is very low, means it forget already learned knowledge. But when we use the lower learning rates, set of range of lower learning rate, the performance is better and the model converge properly. So catastrophic forgetting issue is deal with the learning rate parameter, and for overfitting and underfitting, we use the parameter to monitor the performance of that either it is a model is overfitting or underfitting on validation data.
Okay, but you didn't use the fixed learning rate in these two cases?
No, not fixed. The fixed learning rate could not be used for any task because if we fix the learning rate, it's mean why we are using that parameter as an input. We are fixing.
Wow.
We need to change the parameter. Fine tuning means that we are going to apply the certain range of the parameter.
Okay, thank you.
Yes, welcome. Any other question?
Thank you very much for your presentation, and we should go to next speaker. Sorry,
Okay.
not much
Thank you
time
so much.
for discussion. So.